Okay, good morning, students. So let us start our class. Today, we are going to discuss modulus inequalities. I have a humble request. First, you confirm that you are able to hear my voice very clearly and able to view the screen properly. Could you please confirm?
Yes, sir.
All right, great. So in modulus inequalities, if you notice, dear students, that we, had a very a fundamental definition of modulus. That if you remember what we define as mod x. When mod x is actually defined, so mod x is equal to x if x is greater than 0. And mod x is equal to 0 if x is equal to 0. And mod x equal to minus x if x is less than 0. So let's take an example. If we take mod of 7, we know mod of 7 is 7. Now, that we know without knowing this definition, what I just gave, because we know that mod always return a positive value. So mod of 7 definitely will be plus 7. But if you look into the definition of the function, what I just wrote in the above, so mod of 7, so what is this 7? This 7 is positive, so it should come to the first branch of the definition, that mod x equal to x if x is greater than 0, so it comes at 7. And mod of 0, so obviously 0, it's come to the second branch of the definition. But what is mod of minus 7? So if you see mod of minus 7, what is there inside that mod is negative minus 7, which is less than 0. So according to the definition, what we are getting is that it is mod of x equal to minus x if x is less than 0. So that means it becomes minus of x. But what is x? X is minus 7. And that is why it becomes 7. So the point is that, without knowing this definition also, we know that mod of minus 7 is 7. But how mod of minus 7 is 7, I showed you. So this is the fundamental definition of modulus. Now what we are going to do is that we are going to solve inequations related to this modulus, where we will find inequations where modulus is there. And we will see that how we can solve those equations, and there are proper procedures to do this thing. I will share you the guidelines. We need to follow that guidelines. And along with that, a very fundamental concepts, what I said earlier, that whatever inside that mod, that mod will always return a positive value and always abide by this definition of mod x equal to x if x is greater than 0, mod x equal to 0 if x is equal to 0, and mod x equal to minus x if x is less than 0. Now, what we are going to discuss today is the two things. Let me bring this first, this note. Give me a few seconds so that I can bring it here. So in this section, we will discuss the two cases. The first one is that inequation containing absolute values and their solutions. The first one is that inequalities containing absolute values and their solutions. That is, solution to the inequations like mod of x less than a, mod of x is less than equal to a, mod of x greater than a, mod of x greater than equal to a, in which a is a positive real number. This is the first thing what we will see. And the second thing we'll see is that little advanced one, that is a different form of inequations and their solutions. That is solution to the inequations like f of mod x less than gx. Okay, then mod of fx is less than gx, mod of fx is greater than gx, and mod of fx is greater than equal to mod of gx. These are the different forms of inequations. And we will see, dear students, if we follow the methodology properly, the guidelines, what I'm going to discuss with you today, the questions which are apparently looks like, difficult will not be difficult. Okay. The first one, so first what we are going to discuss today is that inequations containing the absolute values. So what are the fundamentals in the inequations containing the absolute values is something like this. First, let me explain you with a problem and then we'll come back to the theory. Because as you know, it is always, this is one of my teaching style is that always go with an example and then go back to the theory so that it makes more sense and you understand, you connect it properly. So what kind of things we are going to discuss here? We are going to discuss inequations, as I said here, mod of x less than a. Mod of x less than a, it says that this implies that minus a less than x less than a. Always remember this thing. Mod of x less than a tells that x is in between minus a to plus a. Let us solve the problem related to that. After that, we'll bring to all this thing, all the other, different definitions. Mod of x less than equal to a, mod of x greater than a, mod of x greater than equal to a, like that. Let us take an example of mod of x minus 5 less than 2. Suppose we get, problem something like that. Solve the inequation, and you can solve along with me. You can open your notebook. You can do along with me, and so that you can make your understanding absolutely clear. And I'm going not fast. I'm going slowly. So what we are going to do is that we need to solve this inequation. Mod of x minus 5 is less than 2. Now, dear students, as we have just learned that mod of x less than a implies that x is in between minus a to plus a. That means minus a less than x less than a. So from here, what we can conclude? We can conclude that here a is like 2. So minus 2 less than x minus 5 less than 2. Correct, dear students? Now, once it is there, then what we can do? We can take the first part. So let's take, from here we can take two branch out. One is for minus 2 less than, let me use a different color so that you can, so connect it later. Minus 2 less than x minus 5. If I take this one, so what we are going to get? Minus 2 less than x minus 5. So that implies, 3 is less than x because we are adding plus 5 to both the sides. So that implies x is greater than 3. This is one solution we get. Another solution, dear students, if we take this part, that more x minus 5 is less than 2. That also we need to take. So x minus 5 is less than 2 implies what? X is less than 7. Correct or not? So now both these things has to be satisfied. That means that x is greater than 3, that also has to be satisfied, and x is less than 7, that also has to be satisfied. So if we combine these two, dear students, what we are going to get? If we combine these two, we are going to get a solution something like that. 3 less than x less than 7. That implies what? That implies x belongs to the open interval 3, 7. Correct or not? And that is the solution to this inequation. So I'm just explaining that how we can perform this inequation based on that whatever we have just learned. So this thing that mod of x less than a implies that minus a less than x less than a, that you should be knowing. Correct, no, dear students? That you need to, these are the prerequisite knowledge you must be having. Similarly, if we get mod of x less than equal to a, what we can say, dear students? We can say just minus a less than equal to x less than equal to a. Correct, no? Clear or not clear? Absolutely clear?
Yes.
Okay. Now, in the similar manner, if we get that mod of x is greater than a, this implies, you know what, dear students? This implies either x is greater than a or x is less than minus a. So any of these has to be, followed. You take any example, then you'll understand that why it is so. Okay. Similarly, if we get mod of x is greater than equal to a, this implies either x is greater than equal to a or x is less than equal to minus a. Correct, no, students? Okay. So, what the first solution I have done is this, so that I mark it. Now, another problem we are going to do, okay, where we need to use the other properties. Okay. So, the second question, what I'm going to do, dear students, is that, the solve the inequality like mod of x minus 3 is greater than equal to 7. So, let me show you how to solve this one. Let me first, keep the question here. So here the question is that solve the inequation mod of x minus 3, mod of x plus 3 is greater than equal to 7. If you look into this question, dear students, so you will find that mod of x greater than equal to 7 is actually coming into this definition, mod of x greater than a. From here, what we can say? From here, we can say this implies, let me use a different color. This implies either x plus 3 is greater than 7 or x plus 3 is less than equal to, greater than equal to should be less than equal to minus 7. Correct or not? Clear or not clear? So now, so it is either of these has to be true. Now, if when we say that x plus 3 is greater than equal to 7, that implies what? This implies either x is greater than equal to 10 or x is less than equal to minus, I'm sorry, not 10, x is greater than equal to 4, 7 minus 3, no? 7 minus 3 greater than equal to 4 or x is less than equal to minus 10. Now, when we say that x is greater than equal to 4, in set theoric notation, how we can write? This implies either x belongs to closed interval 4 to infinite open interval or x belongs to minus in infinite open interval to minus 10 closed interval. Now or represents what? If you follow my video lectures on sets, you notice that or represent. Can someone please tell me what is or represented by?
Union.
Correct, absolutely correct. Or represented by union. So x belongs to minus infinite, minus 10 Union, sorry, 10 should be closed interval. Union 4 to infinite. This is the solution set. These are the two problems what we discussed, dear students, are very fundamental, very basic, and at the same time extremely important to understand. Because if you understand this thing, then we can go for the relatively complex problem in the next few minutes. So what we discussed now so far, dear students, is the inequation containing absolute values. If you see, in this first example, we took the 2 as the absolute values. And here you see 7 as the absolute values. So what are the guidelines should be followed? I just conclude before we proceed for the other forms of the inequation. Mod of x less than a is implying that minus a less than x less than a. Mod of x less than equal to a is implying minus a less than equal to x less than equal to a. Mod of x greater than a implying either x is greater than a or x is less than minus a. And mod of x greater than equal to a implying either x is greater than equal to a or x is less than equal to minus a. Dear students, these 4 rules you need to completely registered in your mind. Okay, actually if you see from these 4 rules you can make it to 2 rules, because less than a or less than equal to a, that is the only difference of less than equal to, correct now. This is one thing. And the first thing is that as I started saying the definition, this definition is also extremely important to remember, dear students. Fundamental definition of mod you must remember. Okay, we will discuss mod also later when we will discuss complex number. There will also we will discuss we'll see the modulus is also very important at that discussion of complex numbers. But here also in solving linear inequalities, it is also very important, and you see why it is very important. And if you notice that in the last class, what about the few problems we have done, we actually decided that inside mod, it has to be greater than 0. When we did that irrational inequalities, correct? No? When inside square root of something, that we decided that square root of something, what is there? That something has to be greater than 0. Because square root of negative is imaginary number which doesn't belong to the set of real numbers. Anyway, that is a different topic. Now let us concentrate that different forms of inequations, and let us spend some complete focus on this particular topic, that different forms of inequations and how to take care in each of these cases. So, dear students, here I am going to discuss some guidelines. What are the guidelines? First one is that if the inequation is of the form f of mod x is less than gx, then we can conclude that it is a form of a system of inequations like fx is less than gx if x is greater than equal to 0, or f of minus x is less than gx if x is less than 0. F of x less than gx, I repeat, if x is greater than equal to 0, or f of minus x less than gx if x is less than 0. Now, if you get an inequation f of mod x is equal to less than gx, directly solving that inequation is difficult. That's why we actually converted it to a system of inequations. This is difficult to solve. This is not very straightforward to solve. Okay, this is not very straightforward to solve. And that is why we break it down to a system of inequations. And if you remember, dear students, that during the discussion of irrational inequalities, There also we discussed that these are the different guidelines you should follow. Here also the different guidelines we should follow. If you recall that 2nth power 2nth root of fx is less than gx and 2n plus 1th root of fx is less than gx, how we have taken care? The guidelines, if you open the previous test notes, you will get it. Similarly here for modulus. And I repeat, dear students, as I said earlier also, these are not at all important for your board examinations, but at the same time extremely important for entrance examinations. Okay, the next point what I am bringing is that that inequation of the form mod of fx is less than gx. Mod of fx is less than gx is what we are going to discuss now. And we'll see some representative examples also. Let me complete discussing the theory part first. The guidelines. The inequation of the form mod of fx is less than gx is equivalent to the collection of system of following inequations. What is this? That minus fx minus gx less than fx less than gx and gx is greater than 0. This is one. In particular, so that I hope you understand that mod of x is less than a was that minus a less than x less than a. Na? So that is an extension of that. Mod of fx is less than gx. So definitely fx should be between minus gx to gx subject to the condition gx is greater than 0. Subject to the condition gx is greater than 0. In particular, we consider gx equal to a for a belongs to R plus. R plus is a set of positive real numbers. And from mod of fx less than a, what we can conclude is that minus a less than fx less than a. Correct? No? That also we have discussed, but that's why I'm telling that it is a particular case. In particular, if we consider gx equal to a, then this is what we have discussed in the previous topic. That mod of x less than a. We also solved one problem. Now, if a is less than equal to 0, mod of fx less than a has no solution, obviously. Now, how come mod of fx can be less than 0? A cannot be less than 0. No, but I said as a note. If you get some equation, mod of fx less than minus 5, what is the solution? You say no solution possible. But this is the second guideline. So first guideline we see mod of f of mod x less than gx, and second guideline what we see is that mod of fx less than gx. So whenever we solve problem, and we are also solving problem today, okay, then we should always go back to the guidelines. We see that what guideline says. If we follow guidelines, the biggest advantage of following the guidelines is that, it will save your time. And the second advantage is that you are confident that you are in the right track. If you do not follow guidelines, apply your own understanding, that is also not wrong, dear students. But that is time consuming process. It will take time. Okay. Now the third one. Third one is that if mod of fx is greater than gx, then how to solve that one? So mod of fx is greater than gx is equivalent to the collection of system of the following inequations. The first one is that fx is greater than gx or minus of fx greater than gx if gx is less than 0, and fx is less than minus gx, or fx is greater than gx if gx is greater than 0. In particular, if we consider gx equal to a, in particular, like the previous case, if we consider gx equal to a, then obviously a belongs to the set of all positive real numbers. That's why I wrote a belongs to R plus. What we can conclude? Mod of fx greater than a, implying that either fx is less than minus a or fx is greater than a. If you recall, dear students, that's what we did. And if a is less than equal to 0, then mod of fx greater than a has no solutions. Correct? Because you are not sure greater than minus 5, if it is saying greater than minus 5, minus 6 is also greater than minus 5, right now. So then how we can find a solution of mod of fx greater than minus 5? So that is not possible. As if mod of fx is equal to minus 6, there is no solution. So this is the third guideline. And the fourth and the last guideline, dear students, that I'm going to discuss now, when we see that mod of fx is greater than equal to mod of gx. So what to follow at that time? So when you see that mod of fx is greater than equal to mod of gx is equivalent to the system that fx whole square is greater than equal to gx whole square. This is the guideline we should follow when we will see that mod of fx is greater than equal to mod of gx. If you see, dear students, that apart from these four cases, there is no cases left where we are dealing with different form of inequations involving modulus. Correct? It may come to your mind that what happens, sir? You are discussing mod of fx is less than gx. But what happened if mod of gx is less than fx? That is actually equivalent to the case mod of fx less than gx, na? Just interchanging fx and gx. These are the guidelines. Okay, now what we are going to do, dear students, in the next few minutes, we will start solving, few problems where we are going to apply these concepts. This concept, different form of inequations, and the previous concepts also. And what is my humble suggestion to each one of you is open your notebook. You also start doing along with me, and so that you can make your understanding very rock solid, and we can also make a very meaningful discussion. Okay, the first question, what I'm going to do is something like this. In fact, I can give you some time to solve this one. You can also try, because I hope you'll able to do it very well. You can take a couple of minutes to solve this one also, and then we can discuss. Solve the inequation mod of 3x plus 3 by 5 is less than 3. Your answer, as you see, dear students, for all inequations, your answer should be in a set theoretic notation or inequal notation. Done, dear students? or let me do it also so that you can also follow that, the way I'm doing. So what it says, this says that from that, understanding, we can say minus 3 less than 3x plus 3 by 5 is less than 3. Correct, no? Now, we can break it into two parts. Suppose let's take the first part, that where minus 3 less than 3x plus 3 by 5. So what we are going to get out of here is that minus 3 less than 3x plus 3 divided by 5. This implies minus 15 is less than 3x plus 3. In fact, we should multiply both sides by 3. Divide both sides by 3 and the sign of inequality will remain the same. So we can say minus 5 is less than x plus 1. So this implies, minus 6 is minus 6 is less than x, or it implies, x is greater than minus 6. Correct, no, dear students? I hope all of you agree to me that you get x greater than minus 6. Now the second part of the inequation, what comes like this, that 3x plus 3 by 5 is less than 3. 3x plus 3 by 5 less than 5. So what we get here is that, so 3x plus 3 by 5 is less than 3. So here also we can divide both sides of the inequality 3, and 3 being a positive number, the sign of inequality remains the same. So what we get? We get x plus 1 by 5 is less than 1. So from here what we get? X plus 1 is less than 5, because we are multiplying both sides of the inequality by 5, which is a positive number, hence the inequality remains same. So from here what we get? X is less than 4. So now the solution to our inequation should satisfy both, that is, which you see in the green box, that is x greater than minus 6, and also which is there in the blue box, x less than 4. So now let us combine these two. If we combine these two, so what is the solution? What we are going to get is that x belongs to, so we can write first in form of inequation, that minus 6 less than x less than 4. Correct, no, dear students? So from here we can write the solution in set theoric notation. X belongs to the open interval minus 6 to 4. Is it clear, dear students? Absolutely clear.
Yes.
Anyone has any smallest doubt, never hesitate to let me know. Sagnik, Devanshu, Srijita, Disha, Mohor, all are absolutely clear on this one, because these are very fundamental questions.
Yes.
Okay, great, thank you. Now let us discuss the next problem, and you also start doing with me, as I said, dear students, that you should do along with me. Is that mod of, this is also related to the absolute value. So mod of minus 2x plus 5 is greater than equal to 11. You can take a couple of minutes here, students, and then we will solve it together. If you take 2 minutes, so that you will be a little bit ahead of me, and after that, once I start solving, then you can actually reconnect properly. Other than if I start doing now, you may lose this thing, that okay, how said has done this thing. Go back to the fundamental definition. That when mod of x is greater than equal to a, what has to be? What is this one? Okay, dear students, let me also start. If you recall that when mod x is greater than equal to a, what we have done, this implies either, if anyone already found the solution, you can let me know what the solution you get. Either minus 2x plus 5 minus 2x plus 5 is greater than equal to 11, or minus 2x plus 5 is less than equal to minus 11. Correct, not dear students?
Sir, is it -3 to 8 closed interval?
No, it is not. Okay. Let me do it. Then you'll understand. Actually, I got your point, what you wanted to say, but it is exactly opposite to that. It is a complement of that set. So you follow this thing, and then you'll understand where the things went, little different. So from here, what we can get, implies either minus 2x is less than equal to 11 minus 5, that is equal to 6, correct, no? Or minus 2x is less than equal to minus 16 minus 11 minus 5. So from here, what we can say, this implies either, if you divide both sides of the inequality by minus 2, the sign of inequality will get changed. No? So it becomes x is less than equal to minus 3. I think here you got a little bit mistake. You didn't change the sign of the inequality, I hope. And if you divide both sides of the inequality by minus 2 for the second one, so it becomes, x greater than equal to 8. So now it is either of this. So when we say that x is less than equal to minus 3, that implies what? That implies either, in the set theoric notation, x belongs to minus infinite to minus 3, closed interval. Minus infinite, infinite should be always open interval. Correct, no? Or x belongs to closed interval 8 till infinite, open interval. Correct or not? Now, as you said, in the beginning of the classes earlier, is that or means it is a union sign. That implies x belongs to the open interval minus infinite to minus 3 union 8 to infinite. And this is the solution. Now I hope, Mohor, you understand that exactly where things went wrong. Correct, no?
Yes, I am.
Other students, dear students, did you get your point? Did you get this solution? Or if you find something different? Dear Dibansu, you got the same solution?
I got stuck somewhere in between, but yeah.
Now you understood, right?
Yes.
Any doubt, let me know. Sagni, did you get the same solution? Disha?
Okay, first I did the mistake with the x with the three.
Okay. Understood. Now got it. No? Absolutely clear. No? So what I'm saying, see, these are little advanced topic. Definitely, will when you are learning, things will be absolutely, there will be hesitation to, okay, whether I should do this step or that step. But what I say, dear students, follow the guidelines. The guidelines is so important. Guidelines gives us two advantages, as I said. First one is that it reduces our time, and second advantage is that we are confident about our solution. Think about that. Today we have not discussed about the guidelines, but still this question has been given to you. You can approach. But that approach will, you will be approaching that one with little less confidence because there is no guideline that exactly how to proceed. Mod of minus 2x plus 5, you know, yeah, mod means it should be greater than 0. You may tell that minus 2x plus 5 greater than equal to 11 and you get a solution, but it will be a partially correct solution. That is why guideline is important. And henceforth, dear students, means, as I say, means all my class notes, keep it in safe custody. All these class notes are going to help you a lot in future. And this class notes contains both, this class note, the digital record, and also my, voice, what you hear. That also helpful. That means, yeah, said like this. Next problem, dear students, we are going to do now. This is little advanced and I will help you to understand. This is little advanced. The next question, what I'm going to give, little advanced, not very advanced, little advanced, and I'll help you to solve it. Here, what is given, dear students, is that solve the inequation that x square minus mod of 5x plus 6 is greater than 0. Correct me, dear students? So how to solve this inequation? Let's look into it. Apparently it looks like, oh sir, it is little difficult. Apparently. But let's follow the guideline. If you see, one of the guideline we discussed is that mod of fx less than gx. Remember, na, dear students? Correct? So, from this inequation, dear students, what I can write? I can write na, that x square is less than mod of, whenever I write 5 in digital board, it's, little not very clear. So from here, what we can say? From here, we can say that mod of 5x plus 6 is less than x square. As if mod of fx, you can make an analogy with this case, with as if it is the equivalent to the case of mod of fx is less than gx. Now, let us go back to the guidelines and see that what it says when mod of fx is less than gx. If you see, mod of fx less than gx says this thing. What it says? Minus gx less than fx less than gx, and gx should be greater than 0. Correct or not? So that means what is our fx here? In our case, fx is 5x plus 6, na, dear students? And gx is what? X square. Fine. Let us apply that. If we apply that, what we are going to get? We are going to get, this implies minus x square is less than 5x plus 6 is less than x square. And gx is greater than 0. Gx means what? X square, na? X square is greater than 0. This is quite obvious. For any real number x square is greater than 0. So next time onwards, we no need to write this step that and x square greater than 0. Correct or not? So from here, what we can write? Just we can write simply that minus x square less than 5x plus 6 less than x square. Now we have done few times today that we will break into two parts. This is the first inequality, right now, dear students? So what it gives? It gives minus x square is less than 5x plus 6. If minus x square less than 5x plus 6, that implies what? That implies minus x square minus 5x minus 6 is less than 0. If we multiply both sides of the inequation by minus 1, then the inequations will change. So minus less than will be greater than. So x square plus 5x plus 6 is greater than 0. Then what we will do? We will do middle term factorization. What we are going to get? We are going to get x plus 3, x plus 2 greater than 0. Let me write properly 2. Sometime in the digital board this happens. Plus 2 is greater than 0. Now I will just want to make it elaborate. So always we prefer to write in terms of minus 3 into x minus of minus 2 greater than 0, correct or not? So then what we are going to get, if you recall, that x minus alpha into x minus beta greater than 0, that means either x is greater than maximum between alpha and beta, in this case minus 3 and minus 2, correct or not? So this implies either x is greater than minus 2, correct na? Or x is less than minus 3. This is one set of solution, but that is not the absolute solution, dear students, because this is we have achieved by taking the first inequation, that x square minus x square less than 5x plus 6. There is another one, na? This part, that is 5x plus 6 is less than x square. So 5x plus 6 is less than x square. That implies what? That implies x square minus 5x minus 6 greater than 0, correct or not? X square minus 5x minus 6 is greater than 0. This implies what? This you can do middle term factorization. You will get something like this. X plus 1 into x minus 6 is greater than 0. Correct or not, dear students? I am not doing the middle term factorization here because this is not a class to learn about middle term factorization, right? So that implies what? That we should express in terms of minus x minus of minus 1 into x minus 6 is greater than 0. Now, same thing, x minus alpha into x minus beta greater than 0. That means either x is greater than maximum of alpha and beta, or x is less than minimum of alpha and beta. That means either x is greater than 6, correct or not? Or x is less than minus 1. Correct or not, dear students? Now what we need to do? So our ultimate solution is to be satisfied by both the solutions which is there in the green box and there in the blue box, correct or not? And the best way to do is that draw a number line, represent everything in the number line, and then you will find how efficiently we are able to find that solution. So let me draw the number line. So if we draw the number line, then in the mid is 0, and in the right hand side it goes to infinite. In the left hand side it goes up to minus infinite. And as I said earlier, that we need to put in the number line those points related to the solutions and in relative position. So what is there? Minus 1, minus 2, minus 3. That should be left of 0. So this is minus 1, this is minus 2, this is minus 3. And then another one is the 6. 6 could be somewhere here. Done. After that, what we'll do? Let's find it out. What is there in the green box? In the green box, solution is what? Either x is greater than minus 2. So open interval, unfilled circle, greater than minus 2. That means each solution set, it goes like this, isn't it, dear students? Or x is less than minus 3. That means either like this. Anyone has any difficulty, please do let me know, because these are the very, very prime time you should actually have a very rock solid understanding. This is what is represented. What are the, green straight line I have drawn, arrowed line, is actually a pictorial description of what is there in the green box. Similarly, for the blue box, what is there? X is greater than 6. x is greater than 6 means what? Like this. Or x is less than -1. Less than -1 means something like this, no, dear students? Correct? Or I can below here. All of you agree to me? Now, this drawing that number line gives us a confidence. Gives us confidence that we need to make an intersection where both the green line and the blue line is there. To tell me what are the intervals where both blue lines and green lines are there. One is from -infinite to -3, na? Then the next one is -2 to -1, na? And then is again therefore 6 to infinite. Correct, na, dear students? All of you agree to me? What I'm saying is that between -2 to -3 in this region, you see that in this region you see na, that both green and blue lines intersect, not intersect, overlapped. In this region also you see that both green and blue line overlapped. And from this region it goes beyond, actually it goes up to infinite, this region. Now you may think, or you may have this question inside you, but you are not able to ask. Maybe you have this question later also, that sir, why it is important to have the overlapping of the green line and the blue line? If you have this question, or if you do not have this question, maybe this question doesn't arise because you didn't come up to that level, I can say is that, you know, whatever is there in the blue box and whatever is there in the green box, both has to be satisfied for each of the cases, because in both these green box and blue box there is a either or statement, but both has to be true at the same time. As both has to be true at the same time, that is why you are taking that overlap portion. Then your question may be, sir, why you are not taking -3 to -2, or why you are not taking -1 to 6? Answer to this question is that if you look into, dear students, from -3 to -2 in the number line, there is no green line, only blue line. Again, from -1 to 6, there is only green line, no blue line. Correct, na, dear students? So we should combine all these things. So the required solution is, so we get the required solution as x belongs to -infinite to -3 union -2 to -1 and union 6 to infinite. And this is the final solution to the given inequation. If you have any simplest doubt, later also, it may possible that class is done, after that, you have this, you come to it in doubt, always, be in touch with me, as I always say. These are the prime time of your learning. These are the time we should be very, 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 very serious and dedicated towards learning. I am not here to give you lectures. I'm just telling you the facts. Correct, dear students? Got it? Now what I'm going to do is that, as we are about to complete our class, I would like to give you a few questions, and that you can solve it, and we will discuss tomorrow during the class. Okay, the few questions I'm going to give you, dear students, just few. There is a reason why just few, because it will help you to think. It will help you to think, yeah, this is the this is the one sir has done, these are the guidelines sir has told to during the class today, and so let me approach those things and apply those things So let me give you those questions. Just give me just a minute. Within a minute, you will get all these questions in front of you. This is the first question, dear student. This is the second one. This is the third one. This is the fourth one. This is the fifth one. These are the 5 questions. Just apply whatever the concept, and sometime if you see which is not exactly coming under the guidelines, then what are the condition you can take? Mod of x where x is greater than 0, mod of x where x is less than 0, different cases you can take. So, for example, one small guideline I can give you, dear students, that you can follow this thing is that suppose you get something like this mod of ax plus b somewhere, and you are not able to, then what are the, how to break into these cases? So you can break into this one as the 2 cases that ax plus b is greater than 0 and ax plus b is less than 0. When you get ax plus b is greater than 0, that means what? X is greater than, I'm not writing more, so you will get another one ranges of values of x, no? And here also you get another ranges of values of x. Based on those ranges of values of x, you can approach the solution. Okay, so this is one guideline. Another one, that whenever you see that not exactly falling into whatever we have discussed, then you can apply that concept also. Okay. Now, as all the DPPs are done, so what I'm going to tell you is that if you have time after solving all these, these 5 questions, I have a humble request is that to, work on one practice test. So I'm just going to share another screen with you, and just to let you know exactly how you can. You come to this website, www.KonarClasses.com. Then all of you are able to view it, dear students?
Yes, sir.
Okay, then you click on login. Go to your login and password. Then after that, what you can do, dear students, you can come to write practice test. Click here only linear inequalities, just linear inequalities, and write practice test. Then you start getting 10 questions. These are the questions up to the quality of different engineering entrance examinations. Remember, students, so these are the questions which are not important for your board examination. Board examination, these kind of questions will not come. For board examinations, what is important? Board examinations is important is here, go for the DPP. See how methodically we proceed, that you should appreciate. That practice test, we didn't say that you should appear now. Practice test is not now for appearing. So I'm just telling you, the first you should appear for the DPP. So if you go to linear inequalities, as you know, linear inequalities, there are how many sets? There are 10 sets of linear inequalities problems. Solving these 10 sets are important first, then you should go for practice test. So these steps you should follow, dear students. Just take a couple of more minutes. First, DPPs, daily practice problems. This will make yourself completely confident that your board examination marks are going to come near to 100. Ideally, it should be 100, but in exam hall, maybe 1 mark or 2 mark may get sometime we lose, not because of our knowledge or this thing, because of circumstances, it may happen. but it cannot be less than 98. That is my guarantee to you. If you solve the DPPs, once DPPs are done, then come to the practice test. Just type your linear inequalities. Now, once it is done, you get again 10 questions here, 10 different questions, every time 10 questions. There are great set of questions here. Once it is done, dear students, then after that what you will do? Then you come to the unit test. Here also you can give linear inequalities. And in this unit test, yeah, you see after DPP you will get UT. You see UT, linear inequalities. Yeah, you see, there's the UTs. These UTs are actually time-bound test. If I click here, no, dear students, so you see, it is a test for, containing 1 hour 40 minutes. All the questions are mandatory. First instruction. Second one is that for selecting correct option to a question, 1 mark will be awarded. For choosing incorrect option to a question, 0.25 mark will be deducted, and no deduction will be made for not attempting a question. Time duration for this test is 1 hour 40 minutes. If you recall, dear students, when I gave DPP's instruction was that you don't need to worry about how much marks you are getting. You should be only worry about that how well you are learning and applying this learning in your in terms of the solutions. But here it is completely different. So first DPP, then practice test, then unit test, right test. You will start getting 50 questions. And time left is also shown in the left hand side, dear students, as you see. 100 minutes, na? 1 hour 40 minutes. So as you move down, so your time left is also shown. So anyway, for all these things, there are video demonstration, you can look into it. So this thing. After unit test, what you can do, I'm just cancelling the paper because I'm not going to appear it. After that, it's coming that next one is called MDT, module test. In the module test, you will find that in mathematics, you will get module test on algebra. The moment you come to the module test on algebra, here you will get 100 questions. And 100 for 100, answering these 100 questions, so number of questions is 100, you see, dear students. And time duration for this test is 3 hours 20 minutes. So algebra consists of what? Algebra consists of, linear inequalities, permutation combination, binomial theorem, complex number, sequence and series. Once all these are learned, then you go for the, module test. You write test here. You will find the questions here. See, it is from the sets. After that, there are several topics are there, 100 questions. Okay, you can go to the next page, per page 10 questions. Okay, this is a function. Very great question, dear students. We have done a very tremendous amount of effort. Not only we have put effort, what we have done is that this is the great piece of software solution we bought. This is one thing. This is about the module test. One module test is done, then you can go for the mock test, which is the actual entrance examination, dear students. Exact entrance examination. Let me show you as I get a time. I'll just take maximum another 2 minutes maximum. You go to the right mock test. You choose a paper, JEE main paper. Okay, JEE main mock test paper for 2020 this year. Your will be coming next to next year. Start paper. You will see, dear students, you will get the questions in the left hand side. This is a proper mock test paper, what you exactly get in your entrance examination. And in the right hand side, you see these are the options. This is the OMR sheet, answer sheet. And this year, JEE main says that there are 25 questions from physics, 25 from chemistry, and 25 from mathematics. Out of these 25 questions in physics, there are 20 questions are MCQ with single option correct, and from 21 to 25, these are integer type questions. That's why you see till 20 you need to choose, and after 21 you need to write the integer value of that answer. Similarly, from 27 to 45 MCQ, then 46 to 50, it is integer type. Again, from 51 to 70, it is MCQ, then 71 to 74. And this thing is that integer type. Similarly, there are paper for NEET, like that. Those who are interested for medical entrance examination, JEE advanced, all these are available. So with this, I would like to conclude the class, dear students. So what I wanted to say is that a proper guidance along with the proper usage of this online platform from KonarClasses.com is going to make your preparation absolutely rock solid, and with confidence you are going to enter the classroom in the exam hall. In the exam hall, 2 years down the line, when you enter the exam hall, you will enter with a full confidence that I have done all these things under a proper guidance with a proper platform. Then how I can be failed? There is no way I can be failed. With this note, I would like to conclude the class, dear students. If you have any specific question, please feel free to me. All right. Thank you very much.